Our tutorial, Support Vector Machine Regression. Algorithm learning consists of algorithm training within training data subset for optimal parameters estimation and algorithm testing within testing data subset using previously optimized parameters. This corresponds to a supervised regression machine learning task. This topic is part of machine training analysis with our course. Feel free to take a look at course curriculum by clicking link at description box below. This tutorial has an educational and informational purpose and doesn't constitute any type of trading or investment advice. Please read full tutorial disclaimer at the end of this video. Support vector machine consists of supervised boundary-based learning algorithm for predicting output target feature by separating output target and input predictor features data into optimal hyperplanes. Output target prediction error regularization and time series cross-validation are used for lowering variance error surge generated by a greater model complexity. For full reference, I recommend that you read Harris Drucker, Christopher Burgess, Linda Kaufman, Alexander Smola, and Vladimir Babnik, Support Vector Regression Machines, published by MIT Press in 1997. Support vector machines have the following characteristics. A kernel function, which transforms output target and input predictors feature data into higher dimensional feature space to perform linear separation into optimal hyperplanes. For support vector machines, linear, polynomial, Gaussian radial basis, or hyperbolic tangent sigmoid functions are used. As a formula, here we have the example of a linear kernel function, which is equal to the sum from the first to the last of input predictors data multiplied by output target feature data. Quadratic programming, which consists of finding optimal output target feature prediction error penalization coefficient by maximizing separation between output target and input predictor features data support vectors subject to a tolerance margin. As a formula, we have the minimization objective equals to 1 divided by 2 multiplied by the sum from the first to the last of the support vector margin width to the power of 2 plus an output target prediction error penalization coefficient multiplied by the sum from the first to the last of the output target feature prediction error or distance outside of margins plus an output target feature prediction error tolerance margin. Great. So let's go into RStudio so that we can study support vector machine regression with greater detail. Excellent. So here we are within RStudio. The first step within the tutorial is to load its packages. This is done with library function, and within this tutorial we'll be using QuantMud and E1071. So we select these two code lines, we click Run or Ctrl Enter on the keyboard. The next step is to create the data for this tutorial, which will be done through data reading. So we create this variable named data equals to read.csv. Within it we have the name of the data file, support vector machine regression data as a plain text file with .csv or comma separated values stored within the working directory. Comma header equals to true. So again, we select the code line, we click Run or Ctrl Enter on the keyboard, and that creates the data object within the global environment as a data frame. So we click on the spreadsheet kind of icon, and that opens the data object for us. We have two columns of data. First we have dates, and then we have SPY adjusted. SPY is the ETF investment vehicle which intends to replicate the Standard & Poor's 500 index. Adjusted because this includes adjusted close prices which were adjusted for dividends and splits. We have data with a daily frequency from the beginning of 2007 all the way to the end of 2015, therefore 9 years of data. So going back into the code file, next we're going to create a new variable named SPY, which is equal to an XTS or extensible time series composed of data in its second column, SPY adjusted close prices, comma order by equals as date data first column, the corresponding dates. So again, we select the code line, click Run or Ctrl Enter on the keyboard, and that creates SPY variable here as an XTS stored within the global environment. So again, we click the spreadsheet kind of icon there and it opens SPY, which has the same data as data, but now the dates became the index. So going back into the code file, next step is we're going to create target and predictor features. Within this tutorial, target feature is going to be those corresponding SPY adjusted close prices daily returns, and predictor feature is going to be previous day's returns. So first we create a target feature named RSPY equals to daily return, capital R of SPY. This calculates the daily arithmetic rate of return. Then we create RSPY1, which is previous day's returns. Therefore we have it lag RSPY, K equals to 1, the number of periods. And then we're going to create a new variable named RSPYAll, where we're going to bring together RSPY and RSPY1, and we do so with cbind or column bind, and we bring together RSPY with RSPY1. We rename their column names with their corresponding variable names as C for columns, and last, here we are going to remove any rows with non-availables within them with na.exclude. So we select all these code lines, we click Run or Ctrl Enter on the keyboard. The next step is we're going to delimit training and testing ranges within this data. Training range is commonly used for optimal parameters estimation, while testing range is commonly used for forecasting accuracy evaluation. So here we create these two ranges, RSPYT, T for training range, F for testing range, and we'll be using window function. So from RSPYAll for the training range, it's going to be from the beginning of the time series, and it's going to end at the beginning of 2014. Therefore, the first 7 years of data as a training range. And then for the testing range, it's going to be with the start at the beginning of 2014 all the way to the end of 2015, therefore the last 2 years of data. Notice that these training and testing ranges were only included for educational purposes and can be modified according to your needs. So we select these two code lines here, click Run or Ctrl Enter on the keyboard. Within this tutorial, we'll only be working within the training range. So now that we have the data ready, we can continue to calculate the support vector machine regression. For that, we create this variable, SVMT, or support vector machine, and this is done within the training range. And we'll be using SVM function, and first of all, we have the corresponding formula which describes the relationship between target feature explained by predictor feature. Target feature, RSPY, predictor feature, RSPY1. Data is the one found within the training range, RSPYT, and then we have as kernel equals to a linear kernel, and we'll be using as its corresponding parameters cost equals to 1 and epsilon equals to 0.1. Cost corresponds to the output target prediction error penalization coefficient, and epsilon corresponds to the output target feature prediction error tolerance margin. Notice that these values were only included also for educational purposes and can be modified according to your needs. After that, we're going to calculate that corresponding support vector machine regression fitted values with this corresponding new variable equals to predict of that corresponding object we created above, SVMT, and the data we'll be using as the corresponding predictor features is going to be RSPYT, and with $sign we're going to get RSPY1, which is previous day's returns or the predictor feature. So we select these two code lines, click Run and Ctrl Enter on the keyboard. And the last step is we're going to visualize the results within a chart. We do so with plot, in which Y, or the vertical axis, is core data of RSPYT, specifically with $sign we get RSPY, which is the target feature, and the horizontal one, or X, is going to be the core data, also of RSPYT, but we're getting RSPY1, which is the corresponding predictor feature. And then we're going to add points which are going to have as Y, or the vertical axis, those corresponding support vector machine regression fitted values, and as horizontal axis the same as the one above with core data, our SPYT or training range, we get our SPY1, which is the predictor feature, and those are going to be colored in blue. So we select those two code lines, click Run or Ctrl Enter on the keyboard. Excellent. So there we have the chart with us. So we're going to zoom into it. And as we can see, this is a scatter type of chart in which on the vertical axis we have the corresponding target feature, RSPY, horizontal one we have the predictor feature, RSPY1, and we see the corresponding points of the scatter as the corresponding black color dots. And then we see right here as the blue color dots the corresponding support vector machine regression fitted values. Excellent. So we're going to close this chart here. And now that we finished studying support vector machine regression, let's go back into the slides. And as mentioned previously, this tutorial has an educational and informational purpose and doesn't constitute any type of trading or investment advice. Please pause the video now so you can read the full tutorial disclaimer. Okay, so with this, we finished this tutorial. Thank you for watching.